I'm Rob Berline. I am with Sterling Communications and our partner rep firm Simco. Sterling is the U.S. distributor for MSolutions, along with many other brands that we carry. You can find more information about the brands we carry at sterlingcom.com. But for reason we're here today is to get into the world of USB-C and DP alt mode. I'm going to introduce my friend Ariel Marcus. Ariel is the CTO and co-founder of MSolutions, and he'll be our presenter for the day. So Ariel, with that, I will hand it over to you as you walk us through USB-C and DP alt mode.
Okay, thank you, Rob, and thank you everyone who all that join us. As Rob said, my name is Ariel Marcus. I'm the co-founder and CTO of MSolution. I'd like to share today some information about the USB-C in terms of cables, extenders, what type of cables, and so on. I would like to thank Sterling and Simco for hosting this webinar today. A little bit about MSolution. MSolution was founded in 2016 as a design house and manufacturer specializing in advanced USB-C, AV extension, and testing technology. Both me and my partner came from Valens, who invented the HD-Base-T. Both of us were carrying the technical and sales side of distributing the HD-Base-T. And today we are very focusing about on the USB-C capabilities of extending in a professional AV. Today, USB-C is no longer just another connector. It carries power, data, video, audio, Ethernet, and control signals all through a single cable. Yet, many of the installations still run into problems because people assume that all USB-C ports are actually identical. And this is not correct, and this is what we will see. The goal of today's session is to demystify USB-C and to provide practical guidelines what you can apply in your next AV Pro installation. So let's begin by understanding why USB-C has transformed the Pro AV industry. So traditionally, a meeting room or AV installation requires several separate cables like HDMI, DisplayPort for video, USB for data, power for charging, Ethernet for network capabilities, and sometimes separated audio or control cables. USB-C changed this by allowing many of these functions to travel through one connector. And in many cases, it is also a one cable. But this is important to understand. USB-C is not replacing HDMI or DisplayPort. It can transport DisplayPort video, USB data, power, audio, Ethernet, and control together. So the message is very simple. There is one connector, multiple protocol, different capabilities. And that's what we need to understand. One of the biggest misconceptions in the USB-C and the USB is that both of them are the same. USB-C and USB are the same thing. They are not. USB-C is simply the connector. What actually travels through the connector depends on the technology supported by this device, by the cable, by the extender, or by any physical layer that connecting our source device to our sync device. A USB-C port may support, and this is very important to say, it may support USB data, USB power delivery, DisplayPort Alternate Mode, USB 4, Thunderbolt. These are independent technologies, and manufacturers choose which one to implement. That's why two devices with identical USB-C connector can have completely different capabilities. Understanding this is the key to avoid many of the interoperabilities and compatibilities issues in the professional AV. The connector is standardized. The functionality is not. And this is something that we're seeing a lot. The connector of the USB-C, the wiring inside the USB-C are standardized, but the functionality is not. This simplified block diagram show what happened behind the USB-C connector. Inside the typical USB-C system, there are several controllers that are working together. The USB controller manages the USB communication. The MUX router, the high-speed signal to the correct lanes, means either we are using a USB 3.0 or USB 2.0. So this is what actually this MUX router is doing. The power delivery controller negotiates the power between the connected devices. We can run from 5 volt in the traditional USB to 28 volt in high power designs. And it can be reversed, means what we know today as source and device can be swapped during the negotiation, means a laptop can be a device in terms of power, because the controller negotiation can decide that, okay, now we're charging the laptop, so the laptop is getting the power rather than driving the power. Power management circuit deliver the required voltage and current to the device. And when video is enabled, the DisplayPort controller transmits the video stream through the USB-C connector, and it's capturing the lanes of the high-speed wiring inside the high-speed path, let's call it this way, inside the cable or the extenders, and it comes on top of other capabilities of data, for example, that are eliminated or can be partially used. So this is about the power management and the control. We need to understand USB-C is much more than a connector. It's a coordinated system of hardware and protocols that working together, and they must, and that's the main thing, they must be synchronized. Otherwise, you won't get any proper streaming through the lines. As we said, many people still think that USB always provide the 5 volt. That was true in the past, when we used USB 2.0, when we used USB 3 or USB 1 or 1.1 with the full speed and the high speed, all of those, that was correct. We were using a 5 volt. In the USB 3, we were using 0.9 amps, 900 milliamps as a gap that you cannot pass more than it. And in the USB 2.0, it was half an amp, 500 milliamps to deliver. With USB power delivery, the source and sink communicate and negotiate the voltage and power that they can both support. Depending on the application, this can be one of those 5 different voltages. Most of the current devices are using maximum of 20 volt. The new high power devices will consume 28 volt in order to reach up to 240 watt. mainly on Mac and Apple devices that consume such amount of power. So you all heard about terms like source and sink and role swap in the USB world. That's what I mentioned before, that source and sink can swap the direction between them, where devices can even change their roles during the operation. Means we started to charge a device, the device was fully charged. At that point, during the normal operation of the USB-C, we can swap the roles between the source and the device, and between the source and the sink. And then we are enabling the power to drive for a different direction. And this is very important to understand, because USB 2 and USB, only USB in general, is not supported there. Power is no longer fixed. It is intelligently negotiated between the connected devices. And the main thing that we need to understand is that power delivery is communication protocol, not just power supply. Okay? We're no longer just providing the power to the device, because the role can be swapped and can be changed. So in terms of power, we need to understand that. We need to understand the dynamic negotiation and how the power is being driven. In professional AV, power delivery is now part of almost every modern installation. It used to power and charge laptops, interactive display, soundbar, docking station, USB camera, and even complete conference systems. Okay? The power can be driven along the different devices, and each device can become a source of power or a sink of power, consume the power. In today's Pro AV system, reliable power delivery negotiation is just, I can say, as important as reliable video transmission. If the power negotiation fails, the entire user experience can be affected. You know, we cannot allow that extending a video will provide video drops. The same situation is becoming with the power. And the power circuits are becoming very, very critical in the design. Let's talk a little bit about DisplayPort and the alternate mode. DisplayPort Alternate Mode allows video and data to travel through the same USB-C connector. USB-C provides 4 high-speed lanes, okay, that can be dynamically allocated depending on the application's requirements. For maximum video performance, all 4 lanes can be assigned to the DisplayPort, providing high available video bandwidth. But this comes with a price. If the application also requires USB 3, which is the 5 gig or the 10 gig, such as for cameras or touch display or storage devices, the system will be able to allocate only 2 lanes for the DisplayPort, and this will limit us on the video bandwidth and with the performance of the video. And 2 lanes, when we are assigning 2 lanes for the DisplayPort, 2 of the lanes will be used for USB 3. I know that it is very confusing, because all the time when we're talking about USB-C, we're saying we can support video, we can support data. You need to understand, on the connector of the USB-C, the USB 2.0 has a dedicated lines for USB 2.0, and the lanes for USB 3 are actually shared between video, data, high-speed data, and also Ethernet. So we have a mixture of operation, of functionalities, let's call it this way, that are sharing the same lines, physical lines, inside the USB connector. More DisplayPort lanes provide higher video bandwidth, while fewer DisplayPort lanes leave more bandwidth available for high-speed USB data. So the main thing that we need to understand is USB-C intelligently share its available bandwidth between video and USB data based on the application's requirement. This is not something that we can say, okay, now the unit will be fixed only for high-speed data, or now the unit will be fixed only for high bandwidth data, high bandwidth video. And the data, high-speed data, and the video are sharing the same bus, and there is a compromise between both of them in order to have both of them at the same time. And this is something that I'm seeing a lot, and people are getting confused with the capabilities of the cables. So why DisplayPort alternate mode sometimes fails? Okay, what are actually the challenges of the USB-C? The most common reasons for failures are wrong cable, poor signal integrity, wrong lane mapping, and this is important because when you're looking at the USB-C connector, you know that USB-C connector can be flipped on any side. And any direction that you plug it in, it's expected to work. Still, inside the connector, there are two wires that are being used for communication and to determine from which side to get the data streaming. And it's important when you're using a DisplayPort with two lanes and the USB data. Wrong cables, what does it mean? Not every USB-C cable support the DisplayPort alternate mode. Some of them are defined just for USB 3 because they cannot transmit the bandwidth, the full bandwidth requested by the DisplayPort. And some cables are designed only for charging USB 2.0 data, charging and using USB 2.0 data. And I'm seeing a lot of confusion on that. When you're buying, for example, I don't want to say a low cost but a cable that the price is not that high and it's a good cable, but you need to read the small letter. The small letters will say, okay, this is a charging cable, this is a USB 3 cable, this is a cable that can support. They are all look the same, but they are supporting different capabilities. And that's an important part to see. In terms of signal integrity, long or low quality cable or PCB, poor PCB layout means the connectivity to the units that you're using doesn't have, how to say, the best way to be implemented. Those are creating signal integrity issues. When you're using long cables, USB-C, for example, today cannot support on the best way if it is more than 1 meter. Okay, that's the definition, that's the thumb rule for USB-C. There are cables that are longer than that, but they are designed in a better way. They are passing more qualifications, and they can support the longer, but the price will be at the same level. Means better quality, better length on a passive cable, for example. It will be higher with the price. So this is an important part to understand that the quality of the cable is being measured here. If for USB cables, the standard of the USB was defining that it will be able to carry the signals for specific length of the cable, on USB-C, the standard of the USB remove those requirements, meaning that every manufacturer need to be able to be responsible for the length that he is manufacturing. Means he need to make sure and to guarantee that it will support the quality and it will support the signals in a way that they will pass through its cable. Additional thing that we mentioned here is wrong lane mapping or configuration. The 4 high-speed lanes must be routed correctly. An incorrect lane assignment or orientations issues can prevent the DisplayPort link from being established. And that's related to what I said about the pairs of the high speed that we have inside the cable. It is possible that we will use on DisplayLink 2 lanes, only 2 lanes for video transmission, and we would like to use the other 2 lanes for having a USB 3.0. If the configuration of the CC lines, those are the control signals on the cable, will not be implemented properly, we won't get the DisplayPort to be presented correctly. So this is something that is the manufacturer responsibility, but still we need to understand what type of USB-C cables we're taking, because those cables are very critical and very important, and failures can happen without having a real understanding why it is happening. And replacing the cable might solve it, or if it's the same type of cable, it won't solve it. So this is something that we need to understand. Compatibility issues means that both the source and the sink must support the same DisplayPort alternate mode capabilities. Differences in implementation can lead to interoperability problem. If a source is saying I can support only 4 lanes, and the sink is saying I can support only 2 lanes, we won't be able to get video through the channel. And this is something that we need to understand. It's not written, fortunately, it's not written anywhere when you buy the cables, what they are supporting and what they are not supporting. And this is the reason why you need to buy cables for, at least for USB-C, and when you intend to use it in the Pro AV, from a known manufacturer that you can test the cable, verify that it fits your needs, rather than going and buying, on the way, ordering from Amazon a cable and think that it will solve immediately all the issues that you're seeing. It won't happen unless you tested it and verified that it really works for you in advance. Not every USB-C device support DisplayPort alternate mode. That's something that you need to take with you. Not every USB-C cable support DisplayPort video. And not every dock or extender or display support the same alternate mode configuration. This is why I'm saying, and I will say it a lot of times, you must be able to test the configuration of the USB-C with the infrastructure that you are using, that you're going to use in an installation or you intend to buy and use. When DisplayPort mode doesn't work, the problem is usually not the connector. It is the capabilities of the device. And this is something that in many cases I've seen that the connector is being blamed because it's small use. The connector, the USB-C is very small. It has small contacts inside of it, and the connector itself might be damaged. That's true. But it is true if you're trying to do cycling of plug in and out of a USB connector. In many cases, when it doesn't work on the first time, it doesn't mean that the cable is not good or the connector is not good. It's more on the capabilities of the device that the cable is connected to provide all the capabilities that are required by the system. So those are the things that you need to remember when going to implement a USB-C system. Are all USB-C cables identical? Absolutely not. Some connectors, as I said, are completely different capabilities being used, different speed, power, video, distance, and you see it, mainly you can see it on the cost. This is probably the biggest misunderstanding in the market related to USB-C and the USB-C capabilities. There are many different types of USB-C cables, and although they all look the same, they can behave very differently. There are passive cables, there are active cables, there are charging-only cables in the market, and there are cables that are mainly for USB data. Yes. So passive cables contain no electronic. They are ideal for short distance and generally offers the highest compatibility. If all wires are implemented inside the cables, and the length of it is not too long, means it in the range of 1 meter, it shouldn't be a problem. And this could be a passive cable that will have no electronic inside of it, and and it will deliver what you need. Active cables include signal conditioning electronic, means it has what we call e-markers inside the cable. The cable is getting power from the side that it is one of the sides that it's connected to, and using this power, it is driving either through copper or through fiber. It's driving the USB and extending the range of it. Charging-only cables are designed to deliver power, but may not support high-speed USB data or DisplayPort video. Means that those cables has the ability to deliver the 100 watt or more, but they won't be able to deliver DisplayPort or to deliver USB and so on. USB 2.0, USB 3, USB 4, and Thunderbolt cables each support different data rates, bandwidth, and feature sets. Means that we can see cables that are for a Thunderbolt and they do not meet the USB 3 requirements. It is available even though it's not sound logically correct, but yes, there are cables that are able to support only Thunderbolt and not support USB 3 or USB 4, which is supposed to be the equivalent for Thunderbolt. This is something, again, you need to verify on your system. The important point is that every cable has different internal electronics, different capabilities, and different distance limitation. If two USB-C cables look identical, don't assume that they perform the same. Always verify cable specification before troubleshooting the system. You need to understand it's all about the cable here with the USB-C. Those cables are designed for specific implementation. They have a mixed combination of capabilities, and not all of them will fit the system that you need or you're designing. In terms of cable limitations, performance depends, as I said, on the cable length, on the signal loss inside the cable, bandwidth which is supported, power, e-markers inside the active cable. What you need to understand, longer cable is not always better. Higher speed requires better cable quality. In order to be able to transfer the 10 gig, for example, on the USB-C data, USB 3, you need to have a good quality of wiring and structure inside the cable. In order to transfer the DisplayPort Alternate Mode, which can carry signal up to 18 gig or more, you need to have cable that can support this bandwidth. And it's very important to remember that. Common USB mistake that can cause issue. These are the most common mistake we see in the field. We're getting a lot of feedbacks from installers and designers and integrators that are trying to implement using wrong cables. The cable may not support the required USB speed, DisplayPort, or power delivery. You need to make sure that the system is capable. When I'm saying system, I refer to the ecosystem of the USB-C, that it can support whatever you need. Wrong charger. An unauthorized or incompatible charger may prevent proper power delivery negotiation or laptop charging. If you're not using the original charger of the manufacturer, there is a good chance that you will not be able to charge your laptop, for example, with the maximum charging capabilities of the laptop. It really depends on the external power supply that you are providing to the extenders, for example. Unsupported alternate mode. Some USB-C ports support only USB data and charging with no DisplayPort video output. This is something that you need to look on your laptop, on your displays that are using the USB-C. There are different marking for the DisplayPort or the charging or the data, and you need to look for them and understand if they are supported by your system so that you will be able to get the USB-C cables according what you need. No power delivery support. If either device doesn't support PD, charging or certain functions may not work as expected. Means that if we're connecting device and we think that it should be charged or the power supply should be in this way or another, you need to make sure that devices can support it. For example, when we're connecting a USB-C laptop to a display with a USB-C, we need to make sure that the display is capable of charging the laptop. Or if we're putting an extender in between them, we need to understand that the extender is getting enough power to be able to charge the laptop or to power the display. So assuming all USB-C ports are identical is not correct. Two USB-C ports can look exactly the same, but support completely different features. And this is very important. Most USB-C support cases are not caused by the faulty product again. They are caused by mismatch between the capabilities. This is something that we're seeing a lot, and we need to get used to it. When using the USB-C cables and the connectors, we need to understand exactly and verify exactly what we need and how we are using it on the best way. This is an example of a typical modern BYOD meeting room. The user connects a single USB-C cable from the laptop to the extender. The extender then provides all the required connectivity to the room devices, including displays, cameras, speakerphone, and any other equipment which is a USB peripheral. Instead of connecting multiple cables for all the functionality I mentioned, everything is carried over a single USB-C connector. And this is what we are aiming to, okay? And I'm saying what we are aiming to because, again, and I will repeat it many times because I'm getting the complaints of this is not working and that is not working. One USB-C connection can replace multiple independent cables, simplifying both the installation and the user experience. But at the same time, we must, and this is mandatory, we must verify that not just the laptop can transmit a video through USB-C. We need to verify that the cables that we're using are capable of that. We need to understand the extender that we're using, what it is capable of doing, if it can support the 4-lane DP with USB 2.0, or it can support also USB 3 with a 2-lane DP. And we need to understand, we need to do an analysis for the system before we are implementing it, because otherwise troubleshooting will start when we are in the middle of the implementation, and everything we thought that everything will just plug and play. It's not a plug and play. We need to do a background work in order to understand everything. Choosing the right USB-C solutions, okay? The first question to ask is not which product should I buy? It's actually what distance do I need to cover? Up to 1 meter, passive USB-C cable is usually the simplest one. It is cost effective, it provides all the feature, it provides all the capabilities that we need. From 1 to 15 meters, or in some cases even more, an active USB-C cable is maintaining good signal integrity and provide a solution for the USB-C. Again, we need to understand that this active cable can support DisplayPort, or it can support only USB 3. We need to understand the direction that we're connecting the cable. It's not like a passive cable. The active cable has its own requirements in terms of the implementation. Beyond 15 meter and up to 100 meter, we do need a USB-C extender, and the USB-C we need we need to provide what are the functionalities that we need, because there are, we at MSolution, for example, we have a USB-C extender up to 100 meters that support only USB 2.0. We have a USB-C extender that support only USB 3 and USB 2 data. And we have extenders that support both USB and DisplayPort capabilities over the data with over the USB-C extending, with power delivery, and with all the features that are needed. So start by defining the required distance that you need. Then choose the appropriate USB-C solution that will fit your implementation. The right product depends on the application, not just on the connector. That's very important to understand when we're using USB-C and when we're trying to implement the USB-C inside a meeting room or a BYOD environment. Let's talk a little bit about the passive cable. Passive cable are the simplest type of USB-C. It's only wires, no electronic inside of it. The main advantages are it's a low cost most of the time, making it very ideal for a short distance connection. High compatibility, since there is no electronic inside of it. All the wires, assuming all the wires are implemented and connected properly inside the cable, there won't be any problem using it. Plug and play with most of those passive cables, yes, it will be plug and play, because there is, again, no electronics inside of it. If your application is within a short distance, a high-quality passive cable is usually the best and most economical solution. I can tell you that during last Infocom, we presented as MSolution with the Stirling and Simco, we presented a 10 meters passive cable. Okay, a 10-meter passive cable that can be used in implementation. It was tested and verified, but and again, it's the responsibility of the manufacturer, and we as a manufacturer of those USB-C cable, we guarantee that for the 10 meters, this cable will work fully functional, and it is a passive cable. So, as I said, the USB standard is not writing today, is not guiding today with a specific length for passive cables, but they are transferring the responsibility to the manufacturer that when he say that this cable will work for X distance, it will work for that X distance. So you need to understand that, and you need to understand and use the cable based on what you need. Those cables, by the way, are available at Simco and Stirling for testing and for purchase. Let's go a little bit about the active cables. Active USB-C cables are designed for application where the passive cable reach their limits, means we can no longer use the maximum length that we need with the passive cable. Like the passive cable, they contain a built-in electronics that compensate for signal loss, signal integrity, and allowing reliable transmission over the longer distance while maintaining high-speed USB-C data and DisplayPort video performance. But again, on the active cables, you must verify the direction that you are connecting those cables. You must verify the capabilities of those cables, and this way you will avoid interoperabilities or functionality failures, because interoperability is based on the features that are actually supported by the cable. You won't be able to see an interoperability issue of, for example, alternate mode if the cable originally didn't support the alternate mode. So you need to read the small letters saying what are the capabilities of the cable, and then you will be able to use it. They are commonly used in BYOD meeting rooms, conference room, digital signage, and professional AV installation. Although they're more expensive than the passive cable, they provide a much more reliable solution when additional distance is required. And this is, this is why we have those active cables. Active cables extend the distance without sacrificing performance. Okay, we can reach 15 meters without degradation in the performance. And this is what makes them ideal for medium range USB-C installation. This is the USB-C active cables, what it is targeting for. And now let's talk a little bit about the USB-C extenders. When the required distance exceeds the capabilities of the passive or active USB-C cables, the next step is to use a USB-C extender. A USB-C extender can extend the connection up to 100 meters while maintaining all the essential functions, including USB data, DisplayPort, Ethernet, audio control, power delivery. It can maintain all of those. This is where we at MSolutions specialized. Our USB-C extender are designed to overcome long distances challenges while preserving the complete USB-C experience. We provide a reliable solution for modern meeting rooms, and we have tested those extenders with the leading manufacturers of meeting room ecosystem product, like with Cisco, Neat, and many others manufacturers. By the way, the solution that we're providing, comparing to others, is that we are really using a single cable. What does it mean? It means that we get the data, we get the video, and we get the power for charging up to 60 watt or even more with a single connector. I've seen many on the market, many products from competitors that are actually using two cables of USB-C. One is for charging and one is for the DP alt mode. So when distance becomes the challenge, a USB-C extender provides the complete solution without compromising the functionality. And this is very important. What you can see here in the diagram is a simple connection of a laptop to two displays, including a soundbar, including control. This is the MS-DPA HCP. We have an output of HDMI to one of the display. We have an output of USB-C DP alt mode to the second display or to the soundbar. If you are familiar with the installation with many of the soundbar, they have a connectivity for USB-C, and from the soundbar itself, they are driving the HDMI display. So this is what we're seeing here. And everything is being powered from a single power supply and a single USB-C DP alt cable that also drive the power to charge the laptop. So this is what we're seeing here on this slide. And again, those units are available with Simco, and we're shipping them. So MSolutions, let's talk a little bit about at MSolution, what is the portfolio that we're delivering? We're focused on solving USB-C connectivity challenges for the professional AV market. Our portfolio include three complementary solutions families. The first one is the passive USB-C cables for short and medium distance application. Unlike conventional passive USB-C cable that are typically limited to around 1 or 2 meters, we're able to support much longer distance with a passive cable. And that's very important to remember. I really suggest to test it in order to understand that yes, we can drive up to 10 meters with a passive USB-C cable. For USB-C cables up to 10 meters, starting from 15 meters, let's say, we have a line of active USB-C cables. For application that requires longer distance with, let's say, excellent signal integrity and high performance. And the third one is USB-C extender, which are one of our core areas of expertise. Our extenders can deliver the complete USB-C experience, means DisplayPort, data, audio control, and power delivery over a distance of up to 100 meters, 328 feet. And this is without, let's say, without signal degradation, not on the video and not on the data. MSolutions specialize in long distance USB-C connectivity from industry leading passive USB-C cables and up to the extenders that can reach 100 meters, allowing the installers, the integrators to choose the right solution without compromising on the performance. And that's very important when we're using USB-C, and we're seeing that USB-C demand is growing more and more and more. Okay, so as a wrap up, I'd like to leave you with the 5 key messages that I think that I repeated them many, many times during the presentation, but believe me, it's very, very important. USB-C, first of all, is an ecosystem. It's not just a connector, it's embedding multiple technologies working together to deliver the complete user experience. Power delivery is essential for the modern BYOD and the meeting room installation. Without proper PD negotiation of the USB-C, many systems will not operate as expected. We're seeing that on integrations that are failing due to those power delivery requirements. Cable selection matters. It's very important part. Choosing the wrong cable is one of the most common causes for installation and interoperability issue. DisplayPort Alt Mode requires compatibilities. Okay? It's required compatibilities supported by both source and sync device. The cables and any dock or extender must all support the required functionalities. Okay, so when we're using the sink and source, we must verify that we are supporting all the functionalities. Choose the right solution based on the application and the required distance. Whether it's a passive cable, an active cable, or a USB-C extender. I'd like to finish with one message that summarized today's session. The connector of the USB-C may look the same, okay, but the capabilities can be completely different. If you remember that one sentence, you'll avoid many of the USB-C issues that we see today in the field. And I'm seeing them, I'm getting those feedback a lot. And this way, you will be able to design a more reliable professional AV installation. So first of all, I would like to thank you for the attention and attending this webinar, and I'll be happy to answer a question as
Yep.
they are.
Yeah, Ariel, we have a couple questions. The first is from Eric. When you did a presentation of the passive cable, it was labeled at each end host and source. He wants to know, is that truly directional? He would expect that not to matter with a passive cable. So is it directional based on where it goes?
As I said, yes, source and sink and the direction that we're seeing on passive cables, it's not mandatory. Okay, it's not a must. And as I said, the protocol, the controllers that are negotiating can swap the direction. Okay, on passive cable, there is no direction that we need to connect the cable. It's only starting from the active cables and the extenders. On the passive, it's not required. And yes, they can be connected in any direction needed.
Okay. And then we have one more question from Andre. Is there a USB minder type of device that can force the system to use the same configuration? For example, always use 1080p video and USB 3 instead of 4K video and USB 2.
Yes. And yes, in a limited way. If you're using an extender, yes, we can control the EDID and this way to limit the configuration for the resolutions that are being supported. On the passive cable and the active cable, this is not feasible. And as at the moment, I don't think that there is any a small device that can modify or limit the resolution without extending. Means to go in between two passive cables and just limit the capabilities. This
Okay.
is not something which is available. I'm not familiar, at least today.
Okay. We got one other question, and someone wants to know: does a cable that is 40 gigabytes per second USB 4 rated pass DP alt mode?
Yes, those cables can pass DP out mode. Again, it's depend on the capabilities, and it will come on top of the USB 3 capabilities that are running. Again, if it will be all the cable are structured, the USB-C, let's say this way, because it referring to cables, extenders, passive and active cables. The interface of the USB-C is the same. There are 4 pairs of high-speed lanes, and it doesn't matter what the frequency or the bandwidth that they will support. If it is rated a USB 4, for example, and it's defined that it can support 2 lanes of DP video, and 2 lanes for data. So yes, the USB 4 and the Thunderbolt will support the video and the data at the same time. And USB 2 is being supported by default.
Well, thank you very much, Ariel. That is all the questions we have in there. As you can see, there's our contact information on the screen. If you'd like to get in touch with Sterling or Simco about ordering some of these products, getting in demos out, we do have demo equipment. There is Ariel's information on the screen there if you'd like to follow up with him as well, and all the great team from MSolutions. We will have further webinars in the future, so stand by, and we will send information out by that. But thank you everyone for joining us today. We had a great turnout, and have a great day.
Thank you, everyone. Have a great day.